Okay, so this section is called implicit differentiation. And really what you're doing is you're taking the derivative of something that, where you can't isolate y. So you can't get y by itself. This unit is only free response, even though some of these questions could show up on a multiple choice. If they were to show up on a multiple choice, there's certain situations where you wouldn't do them, like you would skip them. And I'll show you a couple of them because I put one in the notes here. But typically, if you have an explicit equation, that's where y is by itself. I can move everything else to the other side, all the x's to the other side, all the numbers to the other side, and all I'm left with is y on one side. An implicit form is if I had like x's and y's on the same side. And in the case that you couldn't get y by itself, so something like an x to the fifth plus x squared y plus y cubed plus 3y squared equals 7, right? I can't get y by itself. There's nothing that I could do to try to factor or anything to just get y by itself. Okay? And I'm going to need to take the derivative of situations like this. Okay? And that's where we do implicit differentiation, which is finding a dy dx. Now, way back in the beginning of time, we had equations of y equals something, and then all of a sudden I changed notation on you and then said, hey, we got f of x now, right? And the one thing that we would always say is y is the same thing as f of x, which it is. Except the only difference is that when I call something f of x, it automatically tells you that it's a function. So it has special characteristics that are more special than just y by itself. If I call something f of x, then that means that my graph passes the vertical line test, so it has special characteristics. Now, if I have y prime, that's the same thing as f prime of x. Only difference is that with an f prime of x, that means that the graph of the derivative is also a function, meaning that it passes the vertical line test. But if I get even fancier, I can call it dy dx, which this notation means the derivative of y with respect to x. And I could take the derivative of x with respect to itself, right? So the derivative of x with respect to x is dx over dx. But we don't do that because dx over dx is just 1. So we typically would never write that because it's equal to 1. When I do implicit differentiation, what I have to do is every single time I take the derivative of y, I have to multiply it by dy dx. And I know that Jacob is going to want to know why. And I will tell you that that if you want to know why, like Jacob, you have to just come and ask me and I can show you. Okay? Most people don't care. There's always a couple of you, though, that do. So, at the end of the day, if you do care about why it works, it comes from chain rule. Because the derivative of y is dy dx. But in the end, if you want further explanation of that, I can show you and send you a couple videos about it. Okay, so there's rules or steps. That's actually what makes this easier, is the fact that we can have steps on how to solve this stuff. Everything in this unit, for the most part, is very recipe-like. It feels like what you've done next door. It's step 1, I'm going to do this. Step 2, I'm going to do this. Step 3, I'm going to do this. Step 4, I'm going to do this. It's very recipe-like. Okay. So If I get to something like this, and I want to take the derivative, anytime I take the derivative of any variables, I am going to treat them as if I was taking the derivative of x. So all of my x derivative rules apply. So power rule still applies, product and quotient rule still applies, chain rule still applies, logarithms, trig, everything, okay? So now what's the derivative of y cubed? 3y squared. Because I took the derivative of y, I have to write dy dx multiplied by that derivative. What's the derivative of y squared? 2y dy dx. Derivative of negative 5y. Negative 5 dy dx. Derivative of negative x squared. Negative 2x, and the derivative of negative 4 is 0. The most commonly missed thing is to forget to take the derivative of all your constants, and then you have random constants floating around everywhere. You must take the derivative of both sides of the equation. That is step 1. Step 2 is I know that it doesn't make any difference which direction I move things for if I want to isolate dy dx. College Board is very specific. They want you to move everything that does not have dy dx to the right side of the equation, which means that I have to add 2x to both sides. Which requires a lot of writing just for the fact that we just moved one term over. That's step 2. Move dy dx terms to the left and everybody else to the right. Step 3 is to factor out dy dx. And when I factor out my dy dx, it is multiplication between dy dx and what I factored out. So in my 4th step, I'm going to get dy dx by itself. So I have to divide both sides by 3y squared plus 2y minus 5. And now your derivative has both x's and y's involved. And that is my answer. Questions that you guys have? Not terrible yet. We are going to go to example 3 and then come back to 2. We will need all of that room for example 2, even though it looks very nice and pretty. So we'll go to 3 first. So what's the derivative of x squared? Derivative of 4y squared? And derivative of 4. Okay, so now I'm going to move my negative. So I'm going to move my 2x to the other side, make it negative. So then I get dy dx is equal to negative 2x over 8y. Now, I understand. You might want to be like, oh, I'm going to, cancel out my 2's, right? And then I'm going to plug in. Because ultimately, I want to find the derivative at this point. So I have to plug in both my x and my y value. The issue is that if I simplify incorrectly and then plug in and I get the wrong answer, then I lose more points. So the way that College Board rubric is you get points for steps along the way. So I would have gotten points for merely just being able to plug in my x and my y into the equation. But if I would have simplified, where I would have accidentally, right? Like what happens if I would have had my dy dx is negative 2x over 8, and I just randomly like reduce this to like negative x over 4, and I forget the y, right? Now when I try to plug in, I'm missing something that I'm supposed to plug in, and so College Board would not give you credit for plugging in because you missed plugging it into one of the variables because you dropped it along the way. So my recommendation is to always plug in first and then to simplify. Okay, so here I would have been able to reduce and get 4, and my two negatives turn into a positive. And the notation is dy dx at root 2 comma negative 1 over root 2. So that coordinate point is in the subscript. And I would have had root 2 over 4 over root 2. So root 2 over 1 times root 2 over 4. I just want to make sure I wasn't messing up. So root 4 over 4, which is 2 over 4, which is 1/2. Great question came up in the other class period, which is, do I have to copy down this notation all the way through? The answer is no, provided that your equal signs line up. But if you're completely disorganized and you write stuff all over the place, then I have no idea what you did. Okay, ultimately, when I go to grade your guys' test, I'm looking for 1 point for you taking the derivative implicitly, 1 point for you getting dy dx, 1 point for you plugging in both your x and your y, and 1 point for your answer. That's how a free response would kind of go. Yes. Huh? Yes. Whole unit. Well, whole unit is free response except for one section that won't show up on your actual test, which is 2-3. Yeah. 2-3 I think is the only one. Okay, questions? Now, in theory, this can show up on a multiple choice test, and typically when it comes to your actual AP test, it will show up once on multiple choice. I'm going to tell you, don't do it. Skip it. The only way you do this question is if you have nothing else better to do. You've done everything else and you've gone back and checked your work on all your questions. Then you can go back and do this question. College Board is specifically trying to put this on a multiple choice to eat up your time. You can do it, it's a polynomial. But how long is it going to take you to get to the end? It could take you more than 2 minutes. So what College Board is trying to do with a question like this when they put it on multiple choice is eat up your time to answer questions on the test. Okay? All right, questions did you guys have? We have to go back to example 2. You ready for this one? So first of all, we have to talk about a little about notation. The notation for the second derivative is d squared y over dx squared. The squared is between the d and the y on the top and next to the x on the denominator. Again, if you're like Jacob, who's going to want to know why the squared is in one spot and one in the top and in one spot in the bottom and they're not the same, then you can come and ask me and I will print out for you when I proved it. Because there was a year that somebody actually cared enough to want to know. So I can print it out for you with the proof. But in the end, that's it. That's the notation for it. You don't really need to know where it comes from, because ultimately, once you've taken a first derivative, you just say that this is the second derivative, and that's the notation. You just have to know what the notation looks like. Okay, so let's take a first derivative. Derivative of x squared is? Derivative of y squared is? And derivative of 25 is 0. So 2y dy dx is equal to negative 2x. Dy dx is equal to negative 2x over 2y. So then dy dx is negative x over y. Not too bad for first derivative. Problem comes in the second derivative. So because I have both variables in the top and the bottom, I have to use quotient rule. So low d high minus high d low over low squared. To the derivative of y, so I have to write dy dx. So d squared y over dx squared is negative y plus x dy dx over y squared. You get some points here. You would get 1 for taking the derivative implicitly. You would get 1 for simplifying. You get 1 for taking the derivative implicitly again. And then you would get another point for recognizing that you have to plug in your dy dx into your equation. Now, if this is free response, you can leave it. However, bless you, I have seen this show up on a multiple choice test. So the answers for the multiple choice are not this. They simplify it further. Before I start simplifying, anybody have any questions so far? Because you're all about to get lost in the algebra. Unless you remember it from last year. Okay, so I'm going to find a common denominator in my numerator. Bless you. So my common denominator in my numerator is y. And then I'm going to write it as one fraction in the numerator. And then I'm going to invert and multiply my denominator. So I have a negative y squared minus x squared over y cubed. I have a common negative that I can factor out in the top. And I could rearrange this, and the reason why I rearrange it is because at the very beginning, x squared plus y squared is equal to what? 25. So this becomes negative 25 over y cubed. That's what they're doing on a multiple choice. That's why I said don't answer this.
Why do they hate us?
Huh?
Why do they hate us?
It's what they do. Yeah, the sad part is that here's your answer, right? And they probably would have had another answer choice where the inside was positive on this step up here, right? Or the y squared was positive. That's how they're getting different variations. Or they would have made this a plus 25 also. So, questions that you guys have? I have to give you an end question, but I will tell you that more than likely what's going to happen is you are not going to finish the end question in class. You will take the end question home, you will finish it at home, and you will bring it to me tomorrow when you do your beginning question. Okay? The reason why is because that is your end question.
Yay.
So, let's be clear about something.
Product rule. Yeah.
You have product rule. And then within your product rule, once you get there, you have chain rule. And that chain rule is a product rule.
That's funny. It's Y1